On worksheet 12, question 10a. We need to solve the equation 3 sine x plus 45 equals 2 for solutions between 0 and 360 degrees, giving our answers to one decimal place. The first thing that I do with a question like this is I make a substitution for the term that's inside the bracket of the sine function. The textbook uses the letter capital X, but I've always used the Greek letter capital Phi instead. Doesn't matter what you use. I then like to change my limits so that I know that I'm getting all the solutions that I need. If the substitution that I'm making is that x plus 45 is equal to phi, I can work out new phi values by plugging these two x values into this formula. So I need solutions where phi is between 45 degrees and between 405 degrees. I'll now solve this equation as I normally would do. Sine phi is equal to 2/3. Phi is equal to the inverse sine of 2/3, which is 41.8. Now that solution is outside of our range of valid answers, but that doesn't mean we've gone wrong. We just use that to find our other solutions. The first thing we do to find other solutions when we're dealing with the sine function is to take away our answer from 180 degrees. 180 take away 41.8 is 138.2. The second thing we'll then do is we'll add 360 degrees to any of our previous answers, or take away 360 degrees from any of our previous answers to find other solutions. And 41.8 plus 360 is 401.8. Now the reason why I worked out these new limits is I want to make sure that I only really write down the ones that are going to lead to valid solutions. And if I add 360 to 138.2, I get 498.2, which is outside my range of answers that will lead to valid x answers, so I'm not going to write it down. Finally though, I don't need phi, I need x, and x is equal to phi take away 45. So I just need to take away 45 from each of these answers. I'm not going to do it to this first one because I know that it's outside my range of data, and if I take 45 away from 41.8, I'm going to get something negative, which is smaller than 0. But 138.2 take away 45 is 93.2, and 401.8 take away 45 is 356.8. And those are my only final answers. In part B, I have to solve the trig quadratic 2 sine squared x plus 2 equals 7 cos x, again giving solutions between 0 degrees and 360 degrees. Now this trig quadratic has got terms of sine and it's got terms of cos, and if I want to solve this I need to be working with the same trig function. I can use the identity sine squared x plus cos squared x equals 1 to replace sine squared x with 1 minus cos squared x. I can then expand my bracket, get all my terms over to one side, and I finish with the quadratic 2 cos squared x plus 7 cos x minus 4 equal to 0. Now I'd expect most trig quadratics to factorise at this point. This one does, and I get 2 cos x minus 1 in my first bracket and cos x plus 4 in my second bracket. If you don't like factoring trig quadratics, let cos x equal c. Write this as 2c squared plus 7c minus 4, and a lot of people will find that factorising easier. I get two solutions, cos x equals a half, and cos x equals minus 4, which I can then solve. Now cos x equals minus 4 has no solutions, because a cos graph only gives solutions between 1 and minus 1. But cos x equals half does have solutions. First one I get from my calculator is 60 degrees. To find extra solutions in a cos graph, I need to take away any calculator answers from 360, and that gives me 300 degrees. I can find extra solutions by adding or subtracting 360 degrees, but these are going to give me solutions above 360 or below 0, so these are my only two answers.